Hello, my name is Opal Smith. Welcome to my presentation on broadband and home networks. The information being presented is found in Chapter 19, pages 233 through 245 of our Communication Technology Update and Fundamentals textbook. Please keep in mind that the information was based on facts that were relevant in 2016, but now there are new updates and more current information available. Next slide. The term broadband is generally used to describe high-speed internet, and what constitutes high speed varies from country to country. The FCC, or the Federal Communications Committee, defines broadband as equal to or greater than 20 megabits per second upload and 3 megabytes per second download time. Speeds in the U.S. are lower, but they continue to rise. They were ranked 16th internationally in 2016 with an average download speed of 12.6 megabytes per second. South Korea, at the time, they ranked first internationally, averaging a download speed of 20.5 megabytes per second. The global average at that time was 5.1 megabytes per second. Next slide. This is now we're getting more into the introduction, and as far as wired broadband is concerned, the 2015 penetration rate of 34 countries averaged 28.79%. Switzerland was leading at that time at 50.55%, and the U.S. averaged 32.12%. Regarding wireless broadband, the average penetration rate was 85.42%. Finland was leading at 138.76%, so they exceeded the 100% mark. And then 6 countries eclipsed 100% penetration at that time, and those countries were Australia, Denmark, Finland, Korea, Japan, and Sweden. Just 1 year later, that list increased to 10 countries, and the United States made that top 10 list at the time. Next slide. Increasing connection speeds associated with technology. There's bandwidth intensive activities with voice over internet protocol television, which is also known as IPTV. And this type of technology is more complex video. It offers more complex video services, and there are versions of the FiOS services and interactive gaming. And also included with this intensive bandwidth activity is wireless home networks. The wireless home networks allowed for multiple computers and devices to be connected to the internet at one time, and these devices include desktop computers, laptops, tablets, smartphones, and audio and video devices, which include stereo systems, televisions, and DVD players. Next slide. Background. So to give you a little bit of background, the broadband networks were using a number of different technologies to deliver services, and among those technologies was the DSL, the digital subscriber line, cable modem, satellite, fiber cable networks, and wireless techniques. Thanks in part to the Telecommunications Act of 1996, broadband providers included telephone companies, cable operations, public utilities, and even private corporations. And we'll talk a little bit more about all of those as we go through the slides. Next slide. Background continued. So let's talk about the digital subscriber line. This is technology that supplies broadband internet access over regular telephone lines, and you hear the term asymmetrical DSL most commonly used when we're talking about DSLs. They download faster than upload, and you use a modem to a phone jack, and you also have the FTTN and FTTH, which is your fiber to node for the FTTN, and that is a hybrid form of DSL, oftentimes referred to as VDSL, or very high bit rate DSL. And then for the FTTH, you have the fiber to the home, which employs fiber optic networks all the way to the home. Next slide. Now we're talking, let's get to the cable modem. The cable television providers, they offered a way for internet to come into the home on the same cable that provides cable television service. And the signals travel to the cable hardened via the cable modem termination system, which is also known as the CMTS. Coaxial cable then ran from the neighborhood node to the home. And the cable modem used a standard called Data over Cable Service Interface. Those were the specifications. 31.5% of all internet households received their internet from cable providers. That was the case, at least in 2016. Next slide. Then you have the satellite, and the satellite was used by a lot of people that lived outside of the DSL's reach and in rural areas without cable. The modem connected to a small satellite dish, but they could not deliver the bandwidth of the cable or the DSL. Next slide. Then you have wireless. There's two types of wireless broadband networks, and that was the mobile and the fixed. The mobile broadband networks were offered by the wireless telephony companies, and they employ at the time that our textbook was written, they employed 3G and 4G networks. And then you had the fixed broadband wireless networks. They used Wi-Fi or WiMAX. Wi-Fi hotspots can be found in many public and private locations. WiMAX stands for Worldwide Interoperability for Microwave Access, and it is also known as IEEE 802.16. Next slide. The broadband over power line, or the acronym for that is BPL. This was one time thought to be the wave of the future, but there were several factors that caused this technology to lose its appeal. Number one, it was susceptible to interference from radio frequency, and the other thing that made it lose its appeal was that other broadband services provided a faster and more reliable connection. Home networks. So at the time, it was at one point too complex and too expensive for home computer owners, so you didn't hear of a lot of home networks at one point. And several factors, though, changed to allow for home networks to take off, and the three of those were the broadband internal access, the multiple complex households, and new networked consumer devices came on the market. Technology and connectivity, it involves like home appliances now, security systems, thermostats, etc., that all include Wi-Fi connectivity. So you're beginning to see the home networks. Then they began to see the home networks take off, and they're still going in that direction. Wired networks. So new housing developments come with structured wiring. Popular features of that structured wiring include home automation, which gives us the ability to unlock doors, adjust temperatures or lights. There is the no new wires networking solutions, and no interference. Now we'll talk about wireless. There are several types of wireless, such as Wi-Fi or Bluetooth or the wireless mesh, also known as Zigbee. Wi-Fi, Bluetooth, and Zigbee was based on the same premise, and that was that low-frequency radio signals from the instrumentation, science, and media, which is the acronym for that is ISM, bands of spectrum, are used to transmit and receive the data. Wireless networks also utilize a transceiver, a combination of transmitter and receiver that is connected to a wired network, generally a router, and is at a fixed location. Wi-Fi is the most common type of wireless networking. Next slide. There were some issues with wireless, and security was one of those. Wi-Fi uses two types of encryption. The WEP, which is the wired equivalent privacy, but that was easily hacked. And then they came out with the WPA, which is the Wi-Fi protected access. The WPA fixed the issues of security by using 128-bit encryption. For the WPA Personal, you use a password. For the WPA Enterprise, you use a server to verify your identity and to make things more secure. Bluetooth enhanced devices can communicate and create an ad hoc network. And then you have Zigbee, which is also known as IEEE 802.15.4, and earlier we talked about the 802.16, but it uses little power and it used the 2.4 gigahertz of radio frequency. Next slide. Residential gateways. The residential gateway is also known as a broadband router, and it makes the router makes the home network infinitely more useful. And now we have, because of routers, we have seamlessly connectivity in the home network to a broadband network so that all the network devices in the home can be used at the same time. Now, so how all of this is working together. So televisions and Blu-ray DVD players regularly come configured with hardware that allows for accessing streamed audio and video content without having to funnel it through a computer. Your cell phones and your tablets are used to access home networks remotely, so you can be away from home and still control the activity in your home just by your smartphone or your tablet. Home networks and residential gateways are the key to the smartphones. Next slide. Net neutrality. So in April 6 of 2010, the court ruled that the FCC has only limited power over web traffic under the current law. In 2014, regulators reaffirmed their commitment to this. Regarding net neutrality, they were concerned that large broadband players such as Verizon and Comcast would have an unfair advantage, and this could stifle innovation. Netflix later made a deal with Comcast in 2014, which caused CommScope's increase the pass-through speed. In February 2015, the FCC voted 3-2 to implement net neutrality. Next slide. Recent developments. In 2014, President Obama reaffirmed commitment to the National Broadband Plan when he called for the connection of 99% of nation's schools to have high-speed broadband service. Then later there was a universal service fund that came about, and in that and as a result of that, we have a surcharge on all phone and internet services, and those fees generate $4.5 billion in revenue. Funds going into the new Connect America Fund was designed to expand high-speed internet and voice service to approximately 7 million Americans in rural areas in a 6-year period. And they had projected that 500,000 jobs and $50 billion in economic growth would be expected as a result of that. So the current status here, and I went to the next slide. So the current status, you see a map here that shows you the broadband penetration history and how many fixed or wired broadband subscribers per 100 inhabitants by technology. So the U.S. has been trailing other developed countries in fiber adoption, which is slowing the amount of data that is being transferred by megabytes per second. And we learned earlier that the United States was ranked 16th, excuse me, internationally as far as how fast they could, get this data, transfer this data per second. And on this screen, we see that they have moved up. And I think at the time, in the previous slide, it showed that they had ranked, they had made it to the top 10. And this chart reflects that as well. And this is information that was current as Q2 2018. So what about getting a job? If you get into the area, if you study in broadbands, or if you want to get into a job that pertains to broadband and home networks, there are two primary areas for employment within the broadband industry. First, there is the support and development of the broadband technology, and then the other area would be as it pertains to content creation, the content creation industry. So if you were wanting to create interactive games or instructional materials or audio and video content, you would look for job opportunities in that field, in that area. And that's the end of my presentation. So now I'm going to click next, and now we get to the questions that I have for you. So I talked about the FCC and their stand or their position regarding net neutrality. So my question is, the future of broadband, number one question is, the future of broadband technology in the U.S. will be directly impacted by the future outcomes regarding net neutrality and by the success or failure of spectrum auctions. As a Christian, would you be in favor of neutrality, net neutrality? If so, how could we use it to advance the kingdom of God? And if not, why? The second question is, tech companies like Microsoft have developed smart homes. Do you believe technologies such as this require humans to be smarter? Why or why not? Thank you.